Okay. This section is special right triangles. There's really 3 of them, but we only have to learn 2 of them. These are very common triangles. They're common architectures too. These are the 2 special right triangles. Anyone know what kind of triangle this is? It's right.
It's a regular equilateral.
It's not all, equilaterals, all sides the same. It's isosceles. These 2 equal each other. So since this is isosceles, how many degrees would each of these be? 45s. So the other special triangle is one like this. This is obviously 90. What would you guess these two are? How many degrees would you guess that and that is?
65.
What? 60 and what? What would the other one have? 60, 30. These are the 2 special right triangles, and there's rules for them that make these very easy to solve. If you've got a 30, 60, 90, there's shortcuts for that. And if there's a 45, 45, 90, there's shortcuts for that. Now, today we're going to do the 45, 45. Tomorrow we don't have class, so next week we'll do the 30, 60, 90. Now, there is shortcuts for these, although you don't need to use them. It just makes it a lot quicker if you remember that. This one, when we get to it, you have to know the shortcuts, or else you won't be able to solve them. 45, 45, you really don't need to. When you have a 45, 45, they may just draw it like that. They may draw it like this. They may draw it like this. So they'll either tell you 2 sides are the same, which means you have to recognize these 2 are 45, or they'll just put one 45 in there, which means the other one has to be 45. So that means the 2 legs are the same, even though it's not marked. Or they have 2 angles marked the same, which means they have to be 45, which means these 2 have to be the same. Okay? So, if they give you one leg, you got to find the missing values. You got to find X and Y. If they give you a leg, the other leg is simple to find. What is it? The same. So X is 8 here, X is 10 here. Legs will always be the same on a 45, 45. Now, to find Y, there's a shortcut, but I'll show you how to solve it. By using the Pythagorean theorem. Which 2?
4.1 and 4.6.
Got 'em.
Why did it stop moving?
It's because you clicked the button first. You clicked the button on the screen probably.
Yes, I see that.
5.1?
Oh.
Okay. So we know the leg is 8 here. And we know this leg is 10. So you can use the Pythagorean theorem to solve this, because the leg squared plus the leg squared square rooted will equal the hypotenuse. 64 plus 64 is 128. And then to simplify it, what perfect square goes into it? Put your iPads away. 64 times 2, which simplifies to 8 square roots of 2. So when I solve this one, we know that's 10 because that's 10, so using the Pythagorean theorem, 10 squared plus 10 squared, square rooted will equal that. 10 squared and 10 squared is 200. What perfect square goes into 200? 100 times 2, which simplifies to 10 square roots of 2. Now some of you may have spotted the pattern already. If you know the leg, what's the hypotenuse going to be?
Oh. Oh.
82.
The hypotenuse on a 45-45 is always going to be whatever the leg is times the square root of 2. So, if this is 7, the other leg is 7, the hypotenuse is 7 square roots of 2. Okay? So that's the shortcut to find the hypotenuse. Now, the other type of 45-45s are these. They gave us a leg. Sometimes they give you the hypotenuse.
Wait, Mr. Hendrickson, you have to know both of the legs?
Yes, you do. But in a 45-45, the legs are always the same.
Okay.
So, we can also use, there's a shortcut for this one. I'll do these two and you can see if you can spot it, like we spotted this one. To find the legs, we know the legs are the same. Even though they may be labeled X and Y, they're the same, so you could call it X and X if you wanted to, right? So, instead of calling that Y, just call it X. So the Pythagorean theorem would be x squared plus x squared equals 12 squared. So an x squared plus an x squared is 2x squared equals 144. Divide by 2. X squared equals 72. So when we square root it, what perfect square goes into 72?
12.
12 is not a perfect square.
Dang it.
36. 36 times 2, which is 6 square roots of 2. So that means this is 6 square roots of 2, and this would be the same.
Next one's 8 square roots of 2, next one's
So you already figured out the pattern? The leg is going to be half of the hypotenuse times the square root of 2. So, in order to find the leg, if you know the hypotenuse, you just take half of the hypotenuse times the square root of 2. Now, sometimes the hypotenuse is an odd number. Okay? If the rule's still the same, 5.5 square roots of 2. Oops. Now, the way they write it in the book, if you look it up, since it's an odd number, they don't put 5.5, they just put 11 square roots of 2 divided by 2. Which is exactly the same, because 5.5 is 11 over 2. So either way is correct, they're both the same answer. Okay? Now, another type of problem is,
So we can write it like 5.
yep, okay? Here, if the leg is 3 square roots of 2,
6.
this is 3 square roots of 2,
6.
and then the hypotenuse is just whatever the leg is, times the square roots of 2, which square root of 2 times the square root of 2 is the square root of 4, which is 2. So 3 times 2 is 6. So it's just doing the rule backwards. If the hypotenuse is 6, remember the leg has to be half of that times the square root of 2. The other one that you'll see is like this. If this is 10 square roots of 2, the hypotenuse, to figure out the leg, we would use the pattern. The leg is half of the hypotenuse, 1/2 times 10 squared root of 2 times the square root of 2. 10 over 2 is 5. Square root of 2 times square root of 2 is the square root of 4, which is 2. So 5 times 2 is 10. Which makes sense, right? Because if the leg is 10, this has to be 10 square roots of 2. Okay?
Is that all we're doing?
That's all we're doing is the 45/45s today. So, again, yeah, they're super easy. If you have a 45/45, we know the two legs, so this is just 7 square roots of 2. The hypotenuse is just the leg times the square root of 2. That's all they gave us, was one example of that. Now, on your assignment today, some of the problems, the last couple I think it is, they tell you you have a square with a diagonal. What that does is it makes it into two 45/45s. The diagonal is the hypotenuse. Okay? So when they tell you to find the diagonal, they're telling you to find the hypotenuse. If they tell you to find the side, you're finding one of the legs. Okay?